2025 Internal Pure Physics 50/50 for exam. It's a long one, so stay focused and keep following the diagram as we move from point A all the way to point E. Question 9. Reads: Figure 9.1 shows a sports car of mass 3,000 kg moving from A to E. The car accelerated from rest at point A at a rate of 2.5 meters per square second with a force of 7,500 N. The car took 5 south to reach point B. Ignore friction and take G equals 10 ms squared. Now, as you look at the diagram, notice the motion. A to B of acceleration. B to D, coasting. D to E, projectile motion. Let's go step by step. Question 9, I. Reads: calculate the linear distance between points A and B. We are told the car starts from rest. So, initial velocity, u equals 0. Acceleration, a equals 2.5 meters per square second. Time, t equals 5s. Now use the formula. S equals ut plus 1/2 times a times t squared. Substitute. S equals 0 plus 1/2 by 2.5 times 5 squared. S is equal to 0.5 times 2.5 times 25. S equals 31.25 m. So, 31.25 meters is the answer. This is the answer because we are calculating distance under constant acceleration. Question 9, 2. Reads: calculate the work done by the force from A to B. Now use the formula. Work equals force times distance. So, work is equal to 7,500 times 31.25. Work equals 234,375 J. So, 2.34 times 10 joules is the answer. This is the answer because work done depends on force and displacement. Question 9, I. Reads: determine the velocity at which the car leaves point D. Now look at the diagram. After leaving D, the car rises to a height of 5 meters in 1.5 seconds. We use vertical motion. H equals ut 1/2 times g times t squared. So, 5 equals u times 1.5 1/2 by 10 times 1.5 u squared. 5 equals 1.5 u 5 by 2.25. 5 equals 1.5 u 11.25. Now solve. 1.5 u equals 5 plus 11.25. 1.5 u equals 16.25. U equals 16.25 divided by 1.5. U almost equal to 10.8 meters per second. So, 10.8 meters per second is the answer. This is the answer because we are finding the initial velocity needed to reach that height. Question 9, 2. Reads: calculate the power developed to reach the height of 5 meters. Now use energy first. Energy gained equals m times g times h. So, energy is equal to 3,000 times 10 times 5. Energy equals 150,000 J. Now power is. Power equals energy divided by time. So, power equals 150,000 divided by 1.5. Power equals 100,000 W. So, 1.0 times 10 watts is the answer. This is the answer because power is the rate of doing work. Question 9, C. Reads: state the energy changes as the car moves from A to E. From A to B, chemical energy from fuel changes into kinetic energy. From B to D, kinetic energy changes into gravitational potential energy and back. From D to E, Kinetic energy changes into gravitational potential energy as the car rises. This is the answer because energy is continuously being converted during motion. Question 9D reads, explain why the 7,500 Newton force is no longer useful after point D. Now look at the diagram. After point D, the car is in the air. There is no contact with the ground. So, the engine force cannot act. Only gravity acts on the car. This is the answer because force from the engine requires contact with the ground. That's a full structured question. Once you break it into motion, energy, and forces, it becomes much easier to handle. Keep practicing these, they come up a lot.